Hello everyone. So we are going to talk about the rise of small language models. I mean, based on the, based on the introductions, I know that you were already working on AI and some ML, and also people coming from the cloud consulting background and cloud background. I think I'm going to cover uh, basically broader ideas around around what exactly are small language models. I might go a bit more technical, but if in case you feel like it's more technical, or if I'm talking about terms which are pretty new to you, please, you could always reach out to us or put your questions in the chat. We can share necessary resources for you to get you up to the speed. But yeah, there are some a bit more technical details that we're gonna share in this presentation. It's not and the previous session that we had was more on AI agents, which are more towards the software development. Someone who has software development could actually develop AI agents, but this small language models does require some expertise in terms of model training, understanding the model architecture, fine tuning. So there are a few things that you should at least have some basic understanding about. But yeah, let me just go ahead and start off with this presentation. So what are the language models? I mean, language models are something that understand and generate human language. Human language is pretty confusing, I can say, because when you NLP is an area uh, has been really not concrete in terms of when you say I'm going to a bank, it could be a river bank, or it could also be a financial bank, a bank where you go and a financial institute. So bank could mean multiple things based on the context. So that's a really tough problem that everyone wanted to solve prior, like in NLP, since every word could mean multiple things based on the context, based on the previous words. So it's been a tougher problem to solve. But as we scale, as you put out more resources, as you put out compute, we found that things like ChatGPT evolved, where something that they have possessed to generate human language, which is as par with um, an expert, not just generating human language, but also reasoning power. I think these are something that these language models, which are basically are evolved now. They are used in translation, summarization, chatbots. Um, so previously they were like simple statistical models, but now the deep learning really helped to make them evolve over time to get more complex and with larger scale with GPT-3 or even BERT. I think they evolved a lot. I mean, based on the scale and the hardware that evolved over time, the GPUs and all. The language models are getting pretty uh, sophisticated as we move towards in the coming years as we move. So coming to the large language models. So we know language models, but what are these large language models? So large language models are anything that has like billions of parameters on vast data sets. So they are like really extensive knowledge across multiple domains, and that's what because of them being trained on trillions of tokens of data which is coming out from internet, because internet could have data for across different domains. It could be domains of medical domain, financial domain. It could be any domain that's on internet. These large language models are trained on vast amount of data, which is all of internet, to be specific. That's the reason why there are billions of parameters trained on vast data sets. So the advantage of that scale is, according to the scaling laws, you could have this emergent capabilities of reasoning that these large language models have possessed. So if you ask ChatGPT to reason about a specific scenario, you could have it reason based on, it could be like a chatbot. If you are looking for research, you could have these large language model perform that way better. So anyone, I mean, most of you are already using ChatGPTs and other, cloud and models like that, which which does provide results, which does help you to learn things really fast and research things really fast. But the biggest challenge with large language models are their, high computation, and there's a lot of cloud infrastructure that you might need. You see a lot of big players are investing in data centers now, and the biggest constraint for these data centers is energy. Um, and what are the limitations? As I said, resource intensive, high cost, environmental impact. That's really a huge problem now, because every LLM, every small query to a chat GPT would actually burn 10 times more energy than a regular Google search. So these large language models does consume a lot of energy and a lot of water to cool up the data centers, that too with small. um, so there's a significant environmental impact as well with this LLMs. Latency is a huge issue, because you see ChatGPT taking a lot of time for responding. So you might not, the user experience, as we all aware, is not instant, just like every other application that we're used to. It's more auto regressive. So that's every token coming step by step. So the latency is definitely an issue because of these large language models being really huge. There are billions of parameters. So whenever there's a small request, in order to serve your request, these billions of parameters have to be loaded into the memory and then give you an output. For every token, you see these billions of parameters being loaded into the memory. So that's a huge deal. You need huge machines to even inference, not leave apart training. This is just to inference your large language models. Mastan, can you mute yourself, Mastan?
I have muted, I think. I have,
Yeah, thank you. I think that too. Um, and then there also, so yeah, so we're all aware of this limitations of large language models. So then comes the small language models. I mean, uh, due to these constraints of large language models, we do see the similar, we do see there are like small language models that are being evolved, because one of the biggest issue with large language models is um, you cannot deploy them in a smaller environment. Like your iPhones may not have a large language model, because your iPhone doesn't have enough memory on different energy to host them. You definitely need a cloud infrastructure. So you're sending your data to some closed source model provider like ChatGPT, or or OpenAI or Anthropic. You're sending your data to them. Imagine you're a financial firm and you don't want your data to going to some third party. So definitely you need something within your own environment, and you don't need your large language model to be expert on all the domains, because these large language models are trained on all of the data in the internet. So it's almost like it got so much of knowledge which you might not need. All of the knowledge you might not need. You might only need certain part of, so you might only need the model to work for you, not for any cloud provider. These cloud providers, or the model providers, majorly the closed source model providers, will be providing you with an output of, they'll be providing with your inference, but still there's a risk of your data going to them. And so that is where the importance of small language models, the small language models have been evolved, are still evolving. And I think privacy security is a very important aspect that everyone in the industry wants. We don't want bigger models to be to host them, or even we might not need all of the knowledge that these models have. So edge computing, IoT devices, mobile devices, they require lightweight models, and also democratizing AI. It could be accessible to anyone. If you have a small device model that is deployed in a smaller environment, it could be accessible to anyone that they want to use. And limited hardware. We want models to be working on smaller hardware footprint, with limited memory footprint and energy. That's also very priority because of the huge environmental impact that these models have. Microsoft and OpenAI investing in nuclear power plants. They want nuclear power plants to power these data centers. So you would see, I mean, nuclear power plants definitely they are cleaner source of energy, but still that will add more burden to the other coal power plants too, because the energy demand goes up, and you would have a lot of other issues that come alongside with that. So yeah, small language models, they operate efficiently on CPUs and smaller GPUs. So you could also use CPUs to have inferencing. Your models can infer. You could have your own inferencing on CPUs too, because of the smaller footprint, and you could also do it on a smaller GPUs too. And inference time, it's definitely ideal for real-time applications. You don't have huge inference time. It's a smaller, the small language models are anywhere like less than 10 billion parameters when compared with large language models. If you see here, GPT-3 has 175 billion parameters, and a smaller language model like 3.5, which is, so 5 model is basically from Microsoft. They got 6.6 billion, and 3.5 mini is 3.8 billion when compared with 500 plus billion parameters the GPT-4 model has. So it's very significantly smaller. So that really helps in um, in creating, in having a faster inference time. These models have very smaller size, so this could be they could be loaded in memory really fast, and reduce energy consumption, cost effective, and domain specific. This is very important for anyone who are, I mean, into finance domain or healthcare domain, which you are tightly regulated with compliance. You would need your data to be within your environment, and you need the model to be working and domain tuned to your own domain. I mean, you don't need GPT-4 or ChatGPT to answer queries regarding your own data. I mean, uh, those could be, you could, ChatGPT could have a lot more knowledge, which you might not need. And your domain or the reasoning for your own domain, um, uh, uh, you know, could be specific to your own domain. I mean, you don't need reasoning that comes alongside ChatGPT, which has knowledge across different domains. You ask a question on finance, but it also knows about healthcare, and there could be an issue with hallucinations. There could also issues with alignment, compliance, and you would also see issues with owning the model, because ChatGPT, it's still closed source. But if you have a small language model that is fine tuned to your own domain, then you could actually own that model. Yeah, if in case it's an open source model. With a lot of open source models which are out there that you can actually use, which are small language models that you can use and you can host by yourself. So the privacy is guaranteed, and also with less resources and less cost. So that's definitely a win-win situation for everyone. So domain specific fine tuning really makes the small language model stand out. Um, so yeah, if you see, this is a comparison between one of the large language models to the left, Llama 2. I mean, Llama, we do have Llama 3 now. There's also 70 billion parameter model. But if you see every uh, uh, closed source model, even now, the closed source models also coming up with their own small language models. OpenAI, recently came up with GPT-4 O Mini, which is a small language model, providing that as a service. Though it's not, we cannot own that. But Llama models from Meta, they are open source, so you could even have like 7 billion parameter models from Llama series. You could use them, and uh, so these are, on the left side is the large language models. On the right side are the small language models. 5 series is from Microsoft, and you do see other small language models as well over here. So I'll just give a pause here and probably ask some. If anyone has any questions, um, please feel free to ask them now. Or if you want to put it inside here, you can. Yeah, yeah. I'll just give a pause.
Yeah, this is Ranga. It's very interesting so far. Thanks for your presentation. But I have only one question. When you said it's obvious that when you go for domain specific, obviously the complexity or the engineering requirement will be less. But I have one question. Do we have any indicative graph of all domains, if not all, maybe the major domains in use versus the complexity with respect to parameter model? As you said, somewhere in billions, 2 billions. So you showed health and finance as a example, but we have other things like maybe manufacturing or any other models, right? From retail. So do you have any indicative chart or graph which shows typically how it looks like?
Um, is it? I'm sorry, Ranga. You're talking about the graph to
No, no.
show.
When I say graph, I mean see a perspective of different domains. For example, we know
Okay.
which are the domains where we have a lot of a training requirement to the models, then more and more of background data, more parameters. Obviously, right? When you have more parameters and more data, more training required, documentation obviously is going to be large.
Yeah.
So my
Yes.
question was, do you have any specific uh, indicative figures like how would be the parameters with respect to the parameter model from the infrastructure required? Because I'm only thinking the background about the greenhouse effect of the infrastructure on the carbon emission. So if you think that way, do you have any standard graph saying that okay, if you say if you go for health, maybe this should be the typical parameter wise
Okay. Yeah.
complexity?
Yes, I understand. So I understood, Ranga. So basically, in terms of domain, if it is, it could be any domain. I mean, it could be financial, healthcare, even the manufacturing. um, y- Usually there are different kinds of small language models. If you see Phi 3.5 is more of a generalist model, so it's already trained on a lot of generic data. But if you see there are smaller models which are which are only developed for specific domain. So for finance domain, there are some models which are majorly fine-tuned to uh, finance domain, because you could have Phi 3.5 fine-tuned to finance, or it could also be fine-tuned to manufacturing domain. How are you fine-tuning? I mean, we will talk about that in the later slides. There are different ways in which you can teach the small language models, uh, and you can fine-tune them. But if you know regarding the parameter count, it all depends on um, how much data that you are training these models on, how many tokens that you're training that specific model on. So I would recommend not to train anything, because I mean, if you're in an industry where you don't want to, you could, because there are already small language models that are already available which understands language. Maybe they are generic, they know a lot of things, but you can create your own training data. Maybe if it is manufacturing data, create a data set and fine tune the smaller language model, which is generic model, and fine tune that to, or instruction fine tune that in a way that it is more aligned towards your own domain. It could be manufacturing, it could be finance, it could be healthcare. So that is one of the ways in which you can fine tune the small language models to any domain. It all depends on how much data that you got, and how you're fine tuning it. There are a lot of techniques like LoRa, QLoRa, which I didn't added that here in the slides yet. I only added few techniques for how to build small language models in the coming slides. But yeah, I don't have any graph as such on the parameter count, but all the parameter count depends on the amount of because we're not training anything from scratch, but fine tune it, you could still do that by creating your own data set, and then using some techniques uh, to fine tune. Or there are also other techniques like RAG, which is retrieval augmented generation, where you could have your own data within your own environment and have the small language model refer to your data through something called like retrieval augmented generation patterns. Um, so yeah, I don't know if I've answered your question, but
No, no,
yeah,
yeah, no, yeah, I got it. Yeah, you're right. See, I think the two important point what you said has actually given me a good idea about my question itself. For example, as you said, one is the fine tuning
hmm
and how you fine tune. These two are very important. As already, I got your point because what algorithm you're going to use for fine tuning also matters a lot
yes,
compared to what you want to find, how much you want to come to fine tune. Yeah, I think basically you take the existing what available, then try to fine tune, and then more and more you fine tune and go for your specific algorithm, which is it's as you said, finally, end of the day is going to be what you want rather than
yes,
what is available. So I think, yeah, I got the answer. Yeah, thank you, thank you.
yes. Thank you.
And
Um,
just to extend that, Raj, I mean, so may I know what are the major use cases, especially maybe as you are quoting the finance industry.
mhm.
So typically to generate a user guide or to write the code comments or something, is it the major use cases typically that comes under the small language models?
So the small language models could be used across different use cases. I mean, it all depends on
Any
what for.
typical, yeah.
Yeah, I mean, yeah, if you ask me, there are small language models which are good with coding as well. But
Mhm.
can you, you know you could fine tune them to be way better than ChatGPT. Like you have GPT-4 models which could be doing great reasoning. Maybe for a specific domain, it could be finance or anything. But you could make a small language model excel or exceed the performance of ChatGPT or GPT-4 by fine tuning and all of it. And coming to the domain, your question, like which domain, it it could be any domain because these language models are good across because the way the small language models are developed are something they're actually developed from large language models, which I think in the coming slides you will know how exactly that's happening. But these large language models are the ones which are training the small language models, or they are providing data sets that could be used to build the small language models. So that could be across multiple domains, but uh, it also depends on what kind of data are you talking about. Data that is which is internal, or it is public data. But if it is internal data, then it differs. But these models are good with coding, so small language models are really getting way better at coding, and even any large language model is also good at coding because of large amount of code that's already there out there. And coding is more strictly right. Code is a structured format. Your programming language, it always follows a structured format. Your C code could have a structured format, but language could not have a structured format. I could say, how are you, Raja, or how you are, Raja, or they could be kind of difference in terms of the ordering, but it does make the same sense. So basically language is where the large language models still struggle a bit, but reasoning is also very important. So if you ask me, in domains like um, chemistry or medical domain, these are specialty domains because chemistry could have chemical compositions, mathematics could have equations. These models are not that great with mathematics, but there are some specific domain tuned models which are really good at mathematics. So yeah, uh, it all depends on the specific use cases, and also the domain where you're applying these models. I don't know if I mean,
Yeah,
does
it
it?
provides sample information, but basically, I miss some connect because the generative AI, the text what you are generating, basically for the chatbots as well as for the documentation. These are primary use cases I'm seeing across the domains on that. Maybe I'll follow it up.
Yes,
I'll
yes,
catch up once you move ahead. Go ahead.
yes,
I mean,
yes. I mean, yeah, we can come back to your question
yeah,
once
yeah,
again.
sure.
Maybe I'm not. 100% getting your question. Yeah, thank you. Any other questions anyone has?
Hey, hi Rajat, this is Anand.
Yeah.
Raj, this is Mastan.
Yeah, Masan. Let me take. I think is it Anand. Did you?
Yes, yes, yeah.
Yeah, Masan. I'll get back to you.
Yeah.
Anand, go ahead.
Okay.
See, you mean
Uh,
this small language models are application specific?
Uh,
Because we will be requiring whole lot of data to communicate with these models to get the answers, to generate the answers. So with RAG, we can have our own specific data tagged with the large language models. So with the small language models, you said parameters are less. Can these small language models can understand all the sentences we give, or like whatever text we give, or they will be specific to our application domain like healthcare or coding or something like that? And
uh,
what will be the size of a small language model?
yeah. So a small language model could be anything that is less than 10 billion parameters. And coming to your other question, can that be an application specific? Yeah, it can be an application specific because but one thing that might differ from a small language model and a large language model is the reasoning power. Large language model has huge parameters, billions of parameters. So the benefit is they are very good at reasoning within one shot or zero shot. So when I say zero shot, so you go ahead and ask ChatGPT to give you, you give it a math problem and ask it to reason. It can do it in first go, whereas a small language model may not. The quality of a small language model is also not that great. When I'm talking about a small language model that is generic, which is trained on all of data, a lot of data, but not as a same scale as a large language model. But when you want to, when you deal with out of domain, when I say out of domain is something that is your own private data. You could do a RAG as well. So you could use a large language model or a small language model to do the same RAG, but definitely a large language model performance will be way better than a small language models. But that might not be all the time the case. If in case you do engineer the small language model or fine tune it or make it more optimized to your domain, then the small language model performance could outperform the large language model. It all depends on how well you're fine tuning it. So you could make it more application specific. It could be your rack setting in which you're basically retrieving it from chunk of data. It could be your PDFs, your documentation that you have where you're doing extraction or retrieving across different sections in your documentation, or it could also be it could also be a generic, a model that is, that you're just asking questions and getting a response from it without rack. So yeah, these could be application specific. Small language models could be it could be made application specific as well. But as I said, end of the day, it's all about fine tuning and how well you fine tune it.
Is that Raj? Is the training also with the chosen data, the training data for the small language models?
Yes.
The
The
data is the training data is also tuned.
when I say training data is tuned, I mean the training data should be
Selected data, selective data. For
the
large language
selected.
models, we give the full
Yes,
corpus.
yes,
Do you have any methodology for choosing the training data for small language models?
yes, absolutely. Because see, you need to have the training data to be at least aligned to what your training data has been in developing your small language model. Imagine you have your small language model trained on English, but you can't have the small language model do reasoning on Hindi because your
Yeah.
small language model doesn't know Hindi.
Yes.
So your training data has to be specific to how your small language. I mean, first thing you should know, okay, how many what kind of data is actually used to develop your small language model. You could have a specific model only for Hindi or Telugu or Kannada. You could have some model region specific models which does know that language, but you can't expect a model which never actually learn anything about Hindi to and then ask it to fine tune on Hindi. Then your model would not perform well because it never knows what Hindi is. Like it doesn't understand Hindi, but you could probably do it on Telugu. So that is how, I mean, on English. So that is how your training data or the fine tuning, how your training data is, what kind of training data that you're using is also it also depends on what kind of small language model that you are fine tuning that data with.
And
So
you said like what will be the size of these models? Can we deploy on our mobile phones?
there are models that you can deploy on your mobile phone. I mean, if you're using iPhone now, your Apple iPhone with Apple Intelligence has a small language model deployed on your phone. That does summarizations, that does a lot of good stuff. I mean, I don't know if you're using iOS 18 and Apple iPhone 16 now, the recent one, it does have small language model deployed, and that is what powering your Apple Intelligence.
Okay, okay. And one
Yeah.
last question: Can we? Is there any idea of integrating small language models so that one small language model is tuned for specific things, another small language model for other specific data, so they can integrate all small models like APIs or something, small functionalities. Is there
Yes.
anything in your
Yes.
research?
Yeah, I mean, there are a lot of research papers which come up with like that, where you could have different small language models which are all like doing different things, and you have a router which will route the model, the query to an appropriate backend small language model based on, what domain or what question that you ask. There are a lot of research that already there now. There are people who deployed something like people mixture of there's something called mixture of models. There's some paper that was released like few months ago, or maybe last year, I don't remember. But yeah, there are different patterns that you can do this routing in the network layer to different models, just like microservices different from microservices, and you have a API gateway sending the request to the
Yes, yes.
multiple services, just like that. Yeah, there are patterns like that. Yeah, there are different patterns like that.
Still under
Exactly.
research, not
I mean, no, I mean, it's not, then it's just a simple cognitive architecture. I don't think,
okay.
I mean, there's not, I mean, I don't think it's a research problem. It's more of implementation or engineering problem, I can say.
Okay, okay.
Yeah. Uh,
Yeah, you can
Apple already
continue.
has that. Apple already has that. Apple Intelligence does have different small language models. They do use the same thing based on your task. They're having multiple models which are doing multiple things. They could be some model for summarization, some model for generating your emojis, different kind of emojis. Apple already doing that. They have a bunch of models deployed on your phone. Um, any other questions? I mean, sorry, Anand, I think you had a question. Can you go ahead?
Yeah. Okay.
Yeah.
So my question was about Llama 3.2 1 billion instructor model. So basically, whenever you say LLM as well as SLM, the only criteria I see here is based on the parameter count, right? Is there any other, I mean, things that has been taken care?
Um,
Just to segregate
I
a model within.
mean, yeah, I mean, I could say parameter count to be very important because you're saying something is really small, so parameter count definitely makes or draws the line between a large language model and a small language model. That explains why you see, Llama 3, they came up with 1 billion, 3 billion, 7 billion, because that definitely makes a lot of difference.
Yeah,
Yeah.
I could see that those are the SOTA models for now to deploy any models on a on device.
You're were asking me any state of the art models now exist
Yeah.
on device.
Yes.
Yeah, there are a lot of state of the art, but 5.3 is really good. This 5.3 model is a great model to be deployed on mobile phones. There's a lot of Gemma model from Gemini from Google is actually being deployed. It's already been deployed on your phone. I think the Pixel is already powered with Gemma model from Google. And as I said, the other models being your Apple, I don't know what they call. Apple doesn't open source anything, but they do have research papers on Open ELM from Apple. So maybe they're using something like that on your phone. Yeah, I think these are some models that are already there on your phone working now.
Okay. Okay. Fine. Thank you.
Okay, thank you. Okay, I'll just go ahead and continue with the presentation. But thank you. Great questions, everyone. So let me go ahead with the. So I mean, how are we generating these small language models? I mean, there are different techniques to build these small language models. I mean, how did Microsoft build the 5.3 model, which is a small language model? 5.3 model over here. These are like 3.8 billion, 2.7 billion, 1.3 billion parameter models. So there are different techniques to do it. I mean, it's not just specific to your language models, but this could be applied across, like, across any machine learning models too. I mean, pruning and all of these techniques being applied. If you have a huge energy or memory intensive models, you could make them uh, smaller using these techniques. So these techniques are more generic. These are not specific to language models. All the three techniques which I'm going to discuss now. So there are three techniques that we're going to discuss. So pruning. So what is pruning? Pruning is just like, you have this large language model and you are just going ahead and removing some parameters, just going and deleting you know, some millions of parameters from these billions of parameters, like, just going and deleting it and saying, oh, am I affecting the performance, or is it still performing well? Then let me just delete it. And you're reducing the size. So how are you deleting also depends on, is it a structured pruning or a unstructured pruning? I mean, if you see, I don't know if someone is new to neural networks, it does have like different kind of, this is how a neural network looks like. There are a lot of activation functions, there's different if it is unstructured, you're just deleting like some of the weights, you're just removing, and you're just you're just having you're achieving uh, you know high compression is just reducing the size of it. And then if it is structured, then you probably are removing like one entire neuron or one entire layer from your neural architecture, from your neural network. So it all depends on how you're removing it. But this is one of the ways to create a small language model. You have a large language model, you're just removing some part of it and making it a small language model. Uh, you know, and it's a very popular method, pruning. There's something called knowledge distillation. And this is really a very important method. I mean, this is what been used to build Phi-3 model from Microsoft, and also Llama models are also done in the similar way. It's called knowledge distillation. So imagine you have your, it's almost like teacher and student, pattern, where, you have a teacher pattern. Teacher is a large language model, because large language model has a lot of knowledge. And you have a student model. Student model could be a small language model, and a teacher model teaches the small language model. How does it teach? It generates a lot of data. Let's say if you want your small language model to learn how to, maybe you give it, maybe you want your small language model to predict, financial fraud, maybe from financial statements. And how you could do that? Maybe you could have your large language model generate some financial statements with financial fraud, or maybe with some patterns of financial fraud, and have it train a small language model with the data. And now your small language model has that knowledge. You have that knowledge distilled into the small language model. So your large language model has this knowledge about, oh, you know what, a financial fraud could be happening because they have this pattern within the financial statement could mean a financial fraud. I'm talking about unstructured data here. I'm talking about text domain. Okay, I mean, there could be financial fraud patterns in graphs and all of that, but I'm not going there. I'm just talking about a simple financial statement, just for the sake of example. It could also be any other example as well. Maybe you want to build a small language model to you know, uh, a small language model to probably write a movie, maybe a movie which is specific to a domain, maybe a specific to a language or a culture, or maybe a model to, generate jokes, maybe specific jokes. Then you could have a large language model generate a lot of these jokes, and then you can have a small language model train on that data. Similar way, the model Phi-3 was actually built by Microsoft by having a large language model generate, they call it textbook quality data. So they generate, so I mean, These large language models actually has a lot of data. I mean, you got all of the garbage data also from the internet, and they've been trained on it. So they could hallucinate. They could have data which is harmful. You could have large language model, talk about how to build a bomb, how to create, maybe how to create a bio weapon. You could have this large language model has that knowledge too, but you don't want your small language model to have that knowledge. So how would you do that? So you have this large language model only generate data, which is really good, clean data, which doesn't have any of the harmful information, and which is really high quality synthetic data. That is what Microsoft says. They say in this paper, the 5.3 paper, they say it's called high quality synthetic data that they generate. And you use that data to train a smaller language model like 5.3, or, it could be Llama 1B, or 3 billion parameters, or Gemma. And then the small language model, you know, really performs well without any issues with having sensitive data, or without having with issues with generating some harmful content, because they never learn that content to be in the first place. Whereas a large language model actually learn a lot of it, because it's trained on all of internet, so probably it has that information. So this is the process of knowledge distillation, um, where you have a teacher model train a student model, and the student model is a small language model, and teacher model is your large language model. And there are two kinds of training. There could be white box knowledge distillation, and there's a black box. I mean, it depends on the architecture, on how it is developed, on how these models have been developed. White box is where the small student model has access to the internal states of your teacher model. When I say internal states, it means that different activations, different layers within your model, and all of it. Whereas the black box knowledge distillation is your LLM, like ChatGPT, providing the training data, and your student model just learns that data all by itself. I mean, it's the same process, but one has access to the internal states of your model, and the other one is more of like having the training data generated from these LLMs, and then the student model learns that. Um, an advantage is it does retain a lot of teachers understanding about language and domain language, and it is really good at building models which are really good at which are high performant, and also which are smaller in size. So it's a very popular method, knowledge distillation. I'm also coming to the next technique. It's called quantization. Okay, quantization is a very popular method, and I think there are a lot of models already been trained by this method. Um, so these large language models, um, the size of these large language models is huge because of yeah, there are parameters, they're huge. L- each every parameter could be like a huge floating number. A floating number could be 0.33, or it could be f32, which is 32 digits. A floating number, which is 0.1234 all the way till 32. These are like small um, floating numbers which does math in order to give you an inference. That is how this inference is. I mean, I just want to keep things simple and explaining it in a simple way. But if you don't understand this, I recommend you just doing some ChatGPT or some Googling, and I think you can understand it's not a huge. I think it's almost like matrix multiplying a huge, complicated, floating 32-digit number versus probably doing a 4-digit number. Probably doing like 0.3245 all the way till 32 multiplied by some other 32-bit versus a smaller number versus the other small number. So basically, quantization does mean you're reducing the computation and the storage. Um, Based on that, you basically produce a smaller model. You don't need a huge lot of parameters, and you could have a smaller less parameters and less computation. The model that could be having that could be that has less or smaller floating numbers. So if you see here, There's this called quantization aware. So during training itself, there's a very popular method. It's called quantization aware training. If you see, if you read any research papers, or even all of these models are actually developed or generated using QAT, which is quantization aware. So while training, this is a full precision. Full precision is a large language model, and then what they do is they do a decomposition of this large language. I'm saying decomposition of this, so basically reducing or making this huge floating number to be less complicated. So if it is 1.2, they're just approximating it to 1. If it is 0.2, they're just approximating to 0, because that will reduce the complexity of this matrix multiplication. That's what's happening under the hood. These LLMs are actually doing matrix multiplication. They are just multiplying different matrices together to give you an output. So they're just approximating these 3.1 to 3, 2.3 to 2, so that the multiplication would be very simple, and also you're reducing the overall size of your model. So by doing this, you generate a very small language model, um, and and um, and then what you do is you just fine tune that to your downstream task. I mean, I in the previously I got a lot of questions on, hey, how it could be used to your domain or not. Yeah, you could use it to your domain, but it all depends on how you're fine tuning and what is your training data. And the training data depends on your your domain. It could be finance domain, it could be any of your own internal, it could be also the manufacturing domain that you can use to fine tune this model. So once you get the small language model, which is low precision, and then you get your training data and then fine tune it to work for your domain. You're not generating this model for generic purpose. You're generating it for your own domain. So this is one of the ways to develop one of the small language models through quantization aware training. And one is the other technique is the post training quantization. Is after training, you again what you do is after training you're doing a quantization. This happens during training, and this happens after training. Usually quantization aware training is the go-to method in the industry, because the post training quantization um, usually doesn't result in a model with a good accuracy. So that's the reason why people go with the quantization aware training. That way, your model performance is also accurate enough. But most of them fetch a small language model. Um, so, and yeah, basically the key points, yeah, they are basically small language models, so low power, and you also have a balance of accuracy and resource efficiency. Um, Okay. There is also one more method which I haven't mentioned here, because I don't want to make this too complicated. It's called LoRa and QLoRa. I don't know if anyone really wants to understand that. You can definitely ping me. I'll explain it to you. But it's called LoRa and QLoRa. Um, uh, it's a very famous method to build or fine tune a small language model. So you could create a small language model that is domain tuned or fine tuned to your own into your own domain, but you're using some of a different technique, which I could add here, but it will make this presentation way too technical, which I don't want to get there. So I'm just stopping it here. Any questions so far? Anyone?
So as you said that, the post-training quantization, is it similar to, is it capable of learning it during the runtime as well, to fine tuning?
Learning during the runtime. Okay. So
Continuous learning.
yeah,
If
continuous.
the
No,
calibration
it's
data,
not. No, it is
yeah.
not about continuous. It doesn't learn. I mean, that is a different topic altogether, because that continuous learning comes into a different space. In that case, the model would keep on learning new information, but that also refers to something where model would get new data, and but I mean, a continuous learning could also refer to getting new data, and also it is learning within the context. But post training quantization doesn't mean that, not referring to inferencing. Post training quantization is okay, now you have a large language model which is already trained, and now what you're doing is, it is completely trained, and now you're just going ahead and then this large language model has every parameter which is huge, like this 1.2, 0.2, and everything. After training, you're just going and approximating it, 1.2 to 1, 0.2 to 0, and everything. This is after training. Here, if you see, this entire thing is happening during the training. So the model is, you're chopping off or you're making this numbers less complicated, and also you're training it parallelly so that your model doesn't lose a lot of accuracy. Here, if you see this one, after the training process, you're you're basically quantizing. You're basically making your parameter less complicated, or you're approximating your parameters to be smaller. So this is happening after the training process.
Got it. So yeah,
But it is not during the inferencing though. So I don't get
right.
confused. It's during the inferencing, but not during the training process, or not during someone asking a question and then answering. No, it's not during that. It's just before that, because the whole purpose of this is to generate a smaller model. So after this, a small language model would appear, but there's also a calibration data that you have to calibrate this to, or basically have it a domain tune. You're not even training this. It's just after training, you're just having some some data which is probably RAG data, or it could be some external data that you're referring it to. So it's post training. So that's the reason why this method is not accurate enough, because even the small language model that is outcome of this post training quantization, the performance or the accuracy would be way less when compared with the quantization aware training. Because in quantization aware training, you're training the model, and also you're making your parameters less complicated. So yeah, hopefully I answered that.
Yeah, yeah, that perfect. That I understood it.
Yeah.
But just to understand in a very general, maybe a little high level question, saying that to understand the segregation of the duties here, so these models come with the pre-built some default data sets, or what should, say, take the case of 5.3, you said, what are they available as a pre-built from Microsoft, or what should the business do? The training should happen at business, or from Microsoft also we get some readily trained
So
models.
yeah, so these 5.3 is more generic model. I mean, it is trained on a lot of domain already. It is already
Yeah.
trained on. It does understand English. It does, but it also depends on what kind of model. There's some models which are vision based. If you see this 5.3 mini, but there are also other. If you see this, it also got something called 5.3 vision, so it can also understand images. So it's multimodal. So these are all, but if your business wants to fine tune this, it is possible for you to do that. But in that case, you probably need to have your own training data and then fine tune this 5.3 model according to your own use cases. It could be, it could be any use case that you have. So it could be any domain that you have, you can fine tune it. So
But otherwise, I mean, for generic cases, it is already trained models.
already trained on general. I mean, 5.3 can understand language. It can talk. It can give you jokes. It can answer questions about anything that ChatGPT could do. This 5.3 can do. But the reasoning power is not as far as ChatGPT. If it is the same, then everyone will be using 5.3, right? But why are we not using 5.3? Because the reasoning is not as robust as ChatGPT or the GPT-4 model or Llama's 70B parameter model, because those are bigger models which has better reasoning power than 5.3 model. But can you make 5.3 better than GPT-4 in your own domain? Yeah, you can. How? There are techniques to do it, and LoRa, QLoRa could be one of the methods to fine tune that model and have it domain tuned to your own specific domain. So you're just training it with additional training data, and you're just aligning that to your own domain. And there are a lot of services which actually does that. OpenPipe is one of the service. It's a third party service which help you with that. It's called OpenPipe. There's also Predibase. Predibase is also one of the vendors who helps you with fine tuning your own small language model to to probably do to be way better than the large language model. Basically, they do provide this fine tuning as a service. That is what they're doing. But yeah, these are generic models. 5.3 is a generic model.
Got
Raj,
it.
one more question.
Yes.
Okay.
Yes, right.
Yeah,
So,
Raj.
Yeah.
if we consider any model,
Yeah.
let's say it's a 32 precision model,
Yes.
usually the size of the model will be 4 times the number of parameters we have. Okay. If we consider this 5.3 mini model, it's have around 4 billion parameters. The size of the model would be around 16 GB.
Mm-hmm.
Okay. So even for inferencing, apart from this 16 GB, there will be some a buffer memory we need to use for one inference. Correct?
Mm-hmm.
Okay. So forget about the 5.3. I will take the 1 billion parameter Llama 3 model,
Mm-hmm.
Llama 3.2. So which is basically has 1 billion parameters. 1 billion parameters in the size of the model would be approximately 4 GB.
Mm-hmm.
Okay, that is, I mean, it has a 4.5 GB of model size. Okay,
Mm-hmm.
if I want to infer, I mean, if I want to make a call to get the results, I have to load whole of the 4 GB or 4.5 GB in the memory. Apart from that, some buffer memory for one inference. Correct?
I mean, yeah, you would do that. And also there's something called caching. KV cache comes into picture, which is again, yes, definitely. Yeah, that all has to be in the memory. That's right.
Yeah,
What you're saying
that
is right.
the whole model has to be in the memory. Okay,
Yes, it does have to
even
be in the
keeping apart the buffer, right? Even 4 GB, I mean, for 32-bit precision model, if it has
Mhm.
a 1 billion parameters, sorry, 1 billion parameters, it should be 4 GB. Okay, do you still think that loading a 4 GB memory on a phone, is it a good idea?
I mean, on a phone, um, see, on a phone, it all depends on, as I said, this is again a bigger model for your phone, right? 4 GB would again be a huge model for your phone. So you could
Yeah,
even go smaller. Maybe, you can make this as a teacher model and create a very small model, which could have like 500 million parameters, right? That would be even lesser memory on your, right?
yeah.
So,
Even
said
if
these
you
are
have
all
a,
generic model. These are all generic
int
models.
4, yeah, even if you have a int 4 model, like even if it is an int 4 model, it would need at least around 512 MB.
Mm-hmm.
Okay, so for any edge device, I would say,
Mm-hmm.
if you want to put that in any edge device, usually, is there any parameter you look for a size of a model? Because even 512 MB of a model is, I believe it is still high.
I think what I would say is, what is your task at hand? That is what I would be more concerned about. Okay, I have this on my edge device, but what am I trying to achieve? Right? Am I
Yeah,
trying to achieve summarization of something, or am I trying to achieve some kind of task? Maybe generating emojis, just like Apple does, right? Apple does have these models on their phone, but they are not having a generic model on their phone. If you ask a generic question, what's Apple doing? Apple is relaying that to ChatGPT, because they don't want to take the risk. They don't want your model to answer everything on your phone, because that is really complicated. You don't have a generic model running on your phone. Even 5.3 model probably you could run, but how many tokens per second are you generating? Maybe 2 tokens per second. I mean, maybe two tokens or 3 tokens per every second. That's very less, right? Your user experience get compromised. So these models that I'm talking about, these are not meant to be on your phone and being generic. These could be on your phone, but they could be domain specific. They could be doing a specific task, right? That defines that what makes the difference, right? 5.3 is small. Yeah, it is good for edge deployment, but edge deployment, your edge device, if it is phone, it is even more resource constrained. Then probably you should think about what the task at hand, and then fine tune it,
my question
make
was,
it smaller.
okay. My question was majorly focusing upon,
Mhm.
I mean, on an average, what would be the size of a model when you want to deploy it on a device?
Which device you're talking about?
I mean, any edge device. Maybe let's take an example of a phone itself.
Yes.
Would
So
be around 10 MB, or it will be around 50 or 500 or 1 GB? I mean, I was just trying to understand. Okay, so let's say 5 or even a Llama 3.2 1 billion will be too far away from to be deployed on a mobile, to be frank. Okay,
mhm,
because I cannot accommodate 4 GB of my phone just for one particular model, for one particular inference. Okay, so
absolutely. I mean,
ideally I should get something which should be even very smaller than 1 billion. Okay, let's take
yes.
a half a billion. If I take a half a billion, 4 times it would be around again 2 GB. Let's say half a billion itself, what I would do is I will quantize it, maybe to 4-bit precision int. That would
Mhm,
be around 220 MB,
mhm,
sorry, 250 MB.
mhm.
Okay, I'm basically dividing it by 4 times.
Sure.
Okay, that would be around 250 MB. I
Okay.
mean, I considered uh, uh, half a billion parameterized model,
Mhm,
which is quantized to 4-bit precision.
mhm.
Okay, which would be the size of 250 MB.
Okay.
Okay, so would that be still good, or I'm just talking about, let's say my model, even with the half a billion, even with the int 4, my model is doing fantastically fine for the task in the hand.
Yes.
Okay, let's say it might be summarization, it might be just specific to summarization, it might
Yes.
be only summarization model for whatever the language you want. Okay,
Yes. Yes.
okay, so even if I get a very good small language model, okay, half a billion parameter, 250 MB size, is that good, or
Yes.
do we have to decrease it?
No, 250 MB is perfectly fine. I mean, 250. I mean, when you say, if it is like in terms of parameters, a 270 or 250 to 250 million parameters, model could definitely do better on your phone. I mean, that's
Okay.
definitely something
So
that you can write. There's something like there are LLMs. There's something called mobile LLM. They're like 125, million parameters one, 350 million parameters one. They do run on mobile phone, and
yeah.
they are great.
So
And
this was one
OpenELM.
of the reason I asked
Mhm.
the category. We are dividing the large model into, dividing the large model as well as small model. Okay,
Yes.
because even in your chart, the small language models, if it is taking a 5.3, right, a 4 billion parameter, I would believe if I have any small language model with 4 million parameter, would never fit into an edge device.
I mean,
So
as
would
I
that
said,
be?
edge device also depends on which edge device you're talking about. My car could also be an edge device. You could also say a small fridge could be an edge device. Edge device doesn't have to be your phone. I mean, yeah, definitely phones are definitely available, readily available. A camera could be an edge device, right? So those cameras could have a small, you know, maybe a CPU attached to it, which can have a model deployed on it. So that could be an edge device too, because that is also a resource constrained process, which is running on a battery, right? That could be an edge device. So when you talk about phone, yeah, that's what the reason why I was asking you what could be an edge device, right? If you are specific, then we could talk about like the parameters, or even to what extent it can add load on that device, right? So edge device could be anything. I mean, there are a lot of edge devices, and
Could
phone
we
is
take an
one of them.
example?
Yeah,
Do you mind taking the phone as an example with a
yeah.
little high level game?
Your phone is an example. So what is the question? I didn't get the question properly. So what is the question here?
The capability of holding that model in a phone and its index processor. I guess we are talking about that. Like the number of parameters it could fit in a model running in a phone. So anyway, whole high level view. Could you give like number of parameters it can hold a model that is running on a edge device like mobile? Not
So
necessarily a specific value, but a rough. It,
you're asking the parameters that can fit on your mobile phone. The
uh,
parameters The number of parameters model, the smallest parameter model that can fit on your mobile phone. Is that the question?
Yeah, small or big or average. Yeah, a little bit
Average, yeah.
around
I mean, as I said, it's all depends. As I said, 270, 350 million parameter model can also fit there, or even 1 billion parameter model also sit there, can fit in there, but also depends on, you know, w- I can give you an example of Apple. Apple is using 3 billion parameter model on your phone. It is using 3 billion parameter model on your phone. So, to see the next slide, this is the Open ELM model family. So they got 270 million to 3 billion parameters. So it's built on device AI task, reducing dependence on cloud services. These are the bunch of models running on your iPhone now, which is powering Apple intelligence. So this is even 3 billion parameter model that's actually running on your Apple phone.
Okay.
So the physical size doesn't depend, not necessarily depend on the parameters, right? It also depends on training data on that. It's a combination, it's a factor of both. Probably we have to find a trade-off as per our target environment there.
Yes, and also target task too. Yeah, and the task again depends on your data, right?
Yeah, yeah, data as well as with the mode, I mean, parameter, the quantity of parameter.
Yes, absolutely.
Raj, does quantization automatically reduces the parameter size? Because we are reducing the floating point size.
Yes, the computation. It
Yeah,
does reduce the
computation. Does
computation.
the quantization automatically reduces the parameters also?
When you say parameters, I don't think it will reduce the number of. You're not reducing 70 billion to, you know, you're not reducing the number of parameters. You're just reducing the computation that happens within your phone or in your environment. So quantization is more of memory footprint reduction, because your matrices or whatever you're multiplying would happen really quicker with quantization. If you want to reduce the parameters, pruning is a method to go.
Okay.
Or
And
knowledge
in this
distillation is
context,
also.
Raj, in this context, are you talking about something like one bit LLMs or something like one bit LLMs?
Uh, 1-bit LLM, BitNet is one of the things that came up with. It's a research paper that happened like I think came out last year or this year. I don't remember, but yeah, it's a 1-bit LLMs which came out 1.5. I think yeah, even they can do better job, but they're still in the research phase. I don't think there are any models that are actually deployed with 1-bit. But it is a research area, active research area that's running, which is where you only have 3 bits, which is -1, 0, and 1 to represent all of your parameters. Yeah.
Yeah. Okay. Okay. Okay.
Any other questions? Yeah, hopefully I'm able to answer your questions. Please, if in case you have any more questions, you can definitely always reach out to me. I'm happy to answer those questions. But yeah, I think this is what it is. It's just like Apple, small language model. It got 3 billion parameter model. OpenELM is an open source model that Apple came up with, which you could deploy on your phone. I mean, I don't know if they're using the same family of models on their phone, because Apple doesn't reveal all this. If anyone knows, please let me know. But yeah, I know OpenELM is a research paper from them, and they have a family of models from 270 million to 3 billion parameters. And even in 3 billion parameter model, don't think all of the 3 billion parameters are actually loading on your phone memory. No, they are loading something called there is something called LoRa's. They're loading something called LoRa adapters. So LoRa adapters could be something that is task specific. So whenever you ask it to do summarization, you are basically loading an adapter, a LoRa adapter that is specific or specialized in summarization. I haven't covered LoRa's here. That is the reason why, if
Yeah,
anyone
okay.
already aware of
Can I just
LoRa's,
take a moment?
yeah, Anand, go ahead.
So I was just checking out the model page in Apple. Okay,
Yes.
but their model infrastructure itself is totally different than whatever we use. Okay, they have a very small base model. On top of that, they have adapter models. Okay,
Yes,
whenever they say 3 billion parameter, it's not one whole bunch of model.
yes, that is what I'm.
Basically, yeah. So basically, it will be like I have a 1 billion parameter base model.
Mhm.
On top of that, I have around 10 million parameter based model, which is very specific for summarization. I have 1
Yes.
billion. Yeah. On top of that, I have 10 million.
No, I mean not 10 billion. It's a 10 MB, probably 15 MB. It could be some megabits of adapters. Adapters could be way smaller when compared
Yeah,
with your
the
base.
adapters will be very small. So the 1
So
billion
yeah,
parameter will be the lowest base model, which will be usually high. And on
yes,
top of that, you have some couple of millions based parameters. Okay.
yes,
And you have a bunch of around 8 to 10 adapters they have. So even if you want to load, you might be loading 1 GB plus extra, whatever the MB you have. Okay. But
yes,
again, they are not using a 32. So they are using 16-bit and 8-bit, and I have somewhere seen the 4-bit quantized as well. So it
yes,
would come around, even if I use a 16-bit, it would be around half a GB plus around 750 MB for their specific infrastructure. They might do well.
yes. Absolutely. I mean, yeah, definitely. See, adapters definitely reduce the memory footprint, and also those adapters could be stack specific too, right? They definitely help you out with having your model load that adapter on the fly based on the task that is there, and your adapter doesn't have to be really huge. They could be very small.
Yeah, 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 yeah.
Others
So
who cover,
their
let's
their infrastructure or the way they have modeled itself is entirely different than one specific small model like
yes,
Phi
yes,
or whatever it is, the Llama 1 billion parameter.
yes, absolutely. I mean, Apple definitely doesn't, but they do use adapters. I mean, others. I'm sorry that we went a bit off topic here because adapters are something that is more related to LoRa and QLoRa, which I haven't covered here. But I did cover that in one of the meetups previously, where I did talked explicitly. It was last year in December. I covered that meetup. I mean, I didn't even had this Bengaluru AI meetup with me then. But yeah, it was something which I covered last year. But I can create a different maybe a different meetup event going forward for LoRa's and QLoRa's and how we can create it. But yeah, they they usually are task specific weights that we create. But yeah, I mean, others who will understand this. If you don't understand what we are talking about, you could just ignore. But yeah, just understand that Apple does have some small language models running on your phone, on your Apple phone. That too with Apple. I think the newer version of Apple's Apple phone, not the older one, because those phone hardware is not compatible. That's the reason why Apple wanted everyone to uh, change the device to have Apple Intelligence. Um, in conclusion, as small language models are specialized, efficient, cost effective, ideal for edge applications, and edge could be bunch of devices. Organizations, you could always balance out small language models and LMs based on specific needs and resources. And small language models are definitely game changers because if you ask me, if if the client, if any of our clients wants to start off with AI, then you know going ahead and training a small language model would be an easy option. It would can be a complicated option. The 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 better option is to start off with a large language model, have a large language model, do your RAG, or it could be anything. It could perform all of these tasks. It could do a lot of inferencing. Always collect the data, use something like Langsmith, or it could use something like any of the LangFuse, which will actually create your own data set of the LLM inference, and then use the data set to fine tune or domain tune a small language model. The small language model would be a phase two of your development process. But I would say that that would be one of the ideal scenarios that you can consider. Yeah, maybe starting off with SLM. Yeah, maybe you could, but in that case, you might need a training data, and that may or may not be in the same. And training data itself could be complicated. You might not have your data in the similar format that could be um, uh, favorable for training your small language model. So you could use a large language model, have it work for your domain, use that to be your training data, later on, and then use that to develop or train your small language model. So that would be a phase to phase transition on adopting small language model. So you cannot jumpstart with a small language model unless your environment is already mature enough and all. But yeah, any questions so far? I mean, we are almost done with this presentation.
Raj,
Uh,
this
yeah.
is Mastan. Raj, you talked about knowledge distillation and quantization. Are there any frameworks or still in the under research these concepts? Are there any frameworks or any APIs like
See, I mean, knowledge distillation is this. It is more of a generic method, but there is no framework as such for that, because you could use any framework. Like you could have your own custom framework. I was actually talking about the same thing previously, just before this. Your question is how to do knowledge distillation. First thing is have a large language model generate or infer uh, all of your questions. It could be easy doing RAG, or it could also be doing anything else. Just have that, create your data set, uh, and then use the data set do um, to train SLM or fine tune an SLM. So that is one of the methodologies. And frameworks or tools, I mean, as I said, it could be Langsmith to capture all the data. You could also use, maybe Bedrock or to access your LLMs. And, yeah, it's generic. It's a generic method. So you could use any framework, but it's just about creating data sets and all. So you could use any cloud storage to create your data set, but it has to happen during inference time for every inference to have that data point captured. So the end of the day, that is what you need in order to implement your knowledge distillation. So yeah, you could do that. I was referring to more of like a white box. Um, I was referring to your white box. I'm sorry, a black box knowledge distillation here. So yeah, it's quite possible with using any generic framework. And coming to LoRa and QLoRa, there are a lot of third-party vendors that you can use. Predibase or OpenPipe are something that you can use for creating them, which I unfortunately haven't covered here. Maybe I should have, but I haven't covered here because I thought it would be too technical. Any other questions anyone has?
Yeah. So, how easy or difficult is it to convert the business documents into the training data sets here for small language models?
So when you say your business data, the business data is business documents
Yeah.
in training data set. Um, so basically, if you have your business documents, you could actually use your small language model, um, do something called RAG. So your small
Mm-hmm.
language model does RAG with your business documents. Do you know about RAG?
No, not directly, but does it involve any manual effort in terms of creating the dependent variables? Or do you
Uh,
require structured data to be provided to that, or can it learn from the context from the documents?
from the documents it can learn. So what happens is a small language model. So even it could be also be large language. So how the RAG works is, so these models are not trained on your own business documents are internal, right?
Okay.
So what happens is whenever you ask a question related to your PDFs or your internal documents, the model can actually retrieve retrieve the appropriate data from your documents. So how is it retrieving? It's basically because, even though that is not trained on it, but it can at least understand your these documents. I mean, it can understand the language within it because it understands English, right? So your documents, maybe you have your documents talk about Q3 financial statements, right? So that is
Mm-hmm.
something internal private to your data. So if you ask a question about, okay, what was the sales in Q3, then it will retrieve that Q3 details from the PDF, and
Yeah.
then it will augment that with its query to the model. So what happens is, based on your question, uh, your model would have the context from your documents and your question that you have, and then it will use the reasoning power from your small language model or your large language model to generate the response. So you're asking
Got it.
about the profit in that Q3. So it does understand that from your documents and it will answer to you. Sometimes it might not do a better job at retrieving. That is where you have to fine tune your small language model to do a better job at
Yeah,
retrieving.
yeah, got it. Yeah,
How to do that, you need to again provide it with proper details and all of that stuff. But you could again train it on your documents as well internally. But yeah, this is how RAG works, retrieval augmented generation works. But yeah.
got it. Yeah, thank you.
Raj, from this any LLM SLM?
Masa, I could hear. I cannot hear you. I lost.
See, from any LLM model, can we create our own SLM?
From any LLM, can you create your own SLM? Uh, yes, you can. Because when you say from, because LLM
Any
could be.
OpenAI LLM, OpenAI anything like
You
ChatGPT LLM,
can,
any
you can,
LLM.
because OpenAI LLM and all of them are really good at generating synthetic data, and that could be used to fine
Create
tune.
our own SLM.
Yes, you can create. I mean, are you talking about from scratch? Or are you talking about fine tuning? Mastan, I think you're breaking.
From that, we are distilling, right? We are distilling.
Yes.
Can we distill from any LLMs, not our own LLM, any big large LLM? From that, can we distill?
Yes, you can.
Okay, basically his questions looks like different actually. Here the distilling is basically the output of a large language model taken to train a small language model. I mean, train in the sense to improve the SLM. It is
Mhm.
not like I will get the weights of a large language model and I will break it to, I will
Small
break or
language model. It is not like that. It is not
yeah,
like that.
it's not like that. We cannot do that,
Weights
right?
of, yeah. To train
I mean,
SLM, I will be requiring again data. You mean?
yes, because you need to fine tune, right? You need to fine tune, and that is the reason why you need synthetic data. So, and by generating that synthetic data, that is how Phi 3 is developed, by the way. Phi 3 model is actually is developed using the output from OpenAI API. It generates a lot of synthetic data that is again used to yes, that is in terms of Phi 3, it is actually developed from scratch. So they have they generated 1.2 trillion tokens from OpenAI API, and then use that to develop a model like Phi 3 or Phi 2. But if in case in your case you don't have to generate a model from scratch, unless you are Microsoft or something like that. You could have you could have a task at hand and you're fine tuning your model. Then yeah, definitely you could do the same job. You could have OpenAI or any of these large language model generate synthetic data, and then you can fine tune the Phi 3 model, which is because Microsoft already did a lot of the job, heavy lifting in generating or developing a small language model. Then you fine tune that with the task at hand, whatever task that you have, and fine tune it accordingly.
Okay, Raj. I was with the impression that we can distill means we can take some parameters and we can have our own SLM. Okay.
Uh, no. When you say take our own parameters, are you referring to pruning?
No, no. When you say like a small language model,
Mhm.
which is suitable for my specific ragging or anything, like I need a small model. So from the large model, can I take with reduced parameters with less reasoning? Can I extract from the large LLM a small LLM like a small language model? That's what I
Okay.
understood.
Okay.
Okay,
Okay.
I might
Yeah.
be wrong
No. No.
again.
It's basically, yeah. Yeah. Basically, there are two things. you either you can either develop your own small language model from scratch, or you could fine tune a existing small language model. So in your case, if you really want to have, but that also depends on what are you trying to do with your small language model. Are you trying to build a small language model and democratize that to this community, like how Microsoft did with 5.3? Or are you trying to fine tune that to do a specific task for you?
I'm talking about
Yes.
black box KD, because you
Okay,
said
you're
in
talking.
this
Yes,
PPT LLM API is there. So
yes.
using LLM API,
Mhm.
can I distill a
Mhm.
small language model?
Yes,
Your figures
you
with
can.
training data.
You can do that. That is how 5.3 is developed, right?
Okay.
That is how
Okay.
5.3 is developed, because 5.3 is developed with trillions of 3.3 trillion tokens from
Mhm.
OpenAI API. This is all
Okay.
synthetic data that is generated from OpenAI API. And then they use this tokens or this data to develop a model called 5.3 Mini from scratch, which is a 3.8 billion parameter model from scratch. But in your case, you don't have to do it from scratch. You could just fine tune this 5.3 to your own domain by generating data. If you already have synthetic data from OpenAI API, you can generate synthetic data and then use that to fine tune this 5.3 model.
Okay. So
Because
only
in,
big,
because
large companies like Microsoft only can develop SLMs, not small companies.
small companies, because I mean, it all depends on money, right? If you have money, you can.
Mhm.
It's not about if you have money to generate or develop your own small language model, you can. You need to have GPUs, you need to create your own model architecture, you need to create your transform architecture, you need to create your decoding strategy, you need to have your evaluations, you need to ablation study. These are all things that you need to do.
Well, I was with the impression that from the large language model, I can extract some parameters with less reasoning and create my own. I just can copy the matter that Patrick's parameters and create a
No, no,
small language model.
no. I mean, no, that's not the right, because these
Hmm.
these parameters are like a blob of numbers, right? You don't know what
Yes, yes.
every number mean what. So that is the biggest problem with AI now, the generative AI. These parameters are still black boxes. I mean, this entire model is a black box. We don't
Hmm.
know, it can hallucinate. We don't know which parameter refers to what. Even though there are some studies now, there's sparse auto encoders that cloud and all of these are working on studying the internals of this brain, but still we don't know. A lot of things is uncertain. We don't know. If that is the case, then you might do it in future, but not now.
Okay, Raj.
So any other questions? I do see some. I don't know if these are questions. Okay, so if you all are good, then I might stop this session now, but it was a great session. I mean, I lot of engaging audience. I never had this in any of my previous sessions, but yeah, thanks everyone.